lines and angles. In this, first we will be introduced to the lines. After that, some definition related to lines, and then angles. What are all the types of angles? Those things we'll see. After that, as a combination, what are all the things are possible? We'll see. Okay, how these lines and angles are connected. That one. So line means endlessly it is extending on both directions, which means connection of the points endlessly in both directions. In that, particularly, if we cut that at one point and it extends indefinitely in one direction, then in that case it is called as ray. How it is called? Ray. Okay. Suppose in both directions we cutted the line, then in that case it is called as line segment. Okay. In that, usually how we will denote the line segment? If the point is named as AB means we will write like AB at the top, one line segment we will draw. It is a ray means AB is a ray, like we will write. If it is a line means AB at the top we will draw one line. Okay. In that, collinearity. What is collinearity? Co-linear. Co means together. Linear. So co-line. So co-line means together on a line. Collinear. Okay. So when we'll say these 3 points are given points are collinear, if the given points lie on a line or line segment, whatever, if that lies on a straight line, then it is called as collinear points. Then it is called as what? Lie on a straight line. If not, it is called as non-collinear points. If not, it is called as non-collinear points. Okay. Now these definitions are there: line, ray, line segment, everything. Okay. Suppose one ray is like this, another ray is like this. This may be considered as in this case. Also, this ray is rotated. Likewise, also we will consider. So, in case we have two rays, the rotation, amount of rotation taken by this ray to reach this position, the amount of rotation taken by this ray to reach this position is called as angle. It's called as angle. In that, this ray is the initial ray. Where it starts is called as initial ray, and where it ends is called as terminal ray. Initial ray and terminal ray. In that, we have several types of angles, among which, if the amount of rotation lies between 0 to 90, we will take this angle as what we will take x. If that angle lies between 0 to 90 degree, 0 to 90 degree, then it is called as acute angle. You know that, right? Acute angle. If that angle is exactly 90 degree, then it is called as right angle. If this angle is more than 90 degree and less than 180 degree, the name of this angle is what? Obtuse angle. Yes. Okay. And then if that angle is exactly 180 degree. This is the midpoint. From here, 1/2 rotation it took. This is exactly 180 degree. Then it is called as straight angle. What angle? Straight angle. And the fifth one, if it lies between 180 degree and 360 degree. How come this will lie between 180 degree and 360 degree? Because if angle is like this, from here to there means we'll take it will be less than 90, obviously. What about this angle? If this is initial ray and this is terminal ray, then it is called as a reflex angle. These are all the types of angle. Whenever it is required, we may use these things. Okay. And then next, in a straight line, there are many points. In a straight line, there are many points. In that, suppose we are inserting a ray in one point. So that makes obviously two angles. One is this one, another one is this one. These two angles are different measure. How we will say, how we will denote these are different measure? Either way, we will differentiate one from another. Like these two lines means it is different. Same number of lines we use to denote this. Those two angles are equal. Okay. So these kind of angles, if any two angles has a common ray, then those two angles are called as adjacent angle. These kind of adjacent angles are there, and sum of the adjacent angles is 90 degree. Sum of the adjacent angles is 90 degree. Then those two adjacent angles are called as complementary angles. Those angles are called as what? Complementary angles. And if the sum is 180 degree, then the same two angles are called as supplementary angles. Those two angles are called as supplementary angles. Okay. This happens only for adjacent angles. Okay. In this case, this is a straight line. This also includes a case that it is not a straight line also. This like we may divide here one angle, here another angle. These two angles, this is x, this is y. If these kind of angles has some like 180, 90 degree means we may say it is complementary, supplementary will say. Okay. And if this becomes a straight line like this, in the straight line we have this sum of the angle, sum of adjacent angles is 180 degree. Then this is called as linear pair. What pair? Linear pair. Okay. Clear? Whatever things we have seen, what is line segment, what is ray, okay, those things we have seen. After that, the angles. What is angles? Two rays makes one angle, right? The position, initial position and the terminal position of one ray can be measured using angle, the amount of rotation it took. Okay, and that angles has several types. If below 90 degree, it is called as acute angle. Exactly 90 degree means it is right angle. More than 90 degree means it is obtuse angle. More than 180 degree means it is reflex angle. Exactly 180 degree means it is straight angle. Okay, that's all. And then we have seen adjacent angles. Adjacent angles means two angles having one common ray. That gives us two situations. The sum of adjacent angles is 90 degree, then it is called as complementary to each other. In this case, if sum of these two is 90 degree means x is the complement of y, and we will say y is the complement of x. The same way, if the sum is 180 degree, then those two angles are called as supplementary angles. Okay, so the same way x and y will say one is the supplement of another, and that lies on a straight line, then it is called as linear pair. Linear, wherever we say linear, there is a line inside it. Linear means it denotes a line. Okay, next, two angles are called as vertically opposite angles. Two lines has one common point. Two lines intersect each other at one point. Then in this, the vertically opposite angles means these two are vertically opposite angles. Like we'll name this is x, y, and these two are vertically opposite angles. All of them are different measures. Okay, this includes adjacent angles as well. What you can say about x and z? Adjacent angles. X and z are adjacent angles, as well as they are linear pair. Adjacent angles as well as they are linear pair. What you can say about x and t? Those two also adjacent angles as well as they are linear pair, because that lies on a straight line and sum of them is 180 degree. Okay, what you can say about x and y? Those two are vertically opposite angles. That is what we can say. All as of now, those are vertically opposite angles. Okay, so adjacent angles now that has one common arm, one common ray, and vertically opposite angles means right next opposite to each other. Okay, like the adjacent angles share one property, this vertically opposite angles also shares another property. That property is given in the next theorem, next statement. No, sorry. After that, we come to the statement. So this is about intersecting lines. Suppose this line has no common points. These two lines has no common points. Then those two lines are called as non-intersecting lines or parallel lines. Non-intersecting lines or parallel lines. Okay. Next. This linear pair of angles is there, right? Using that, we are defining an axiom. If a ray stands on a line, if a ray stands on a line, means what? There is a line and a ray stands on it. Okay, then the angle so formed by these two is 180 degree. The angle so formed is 180 degree. So because this is a straight angle, right, as per the definition, so only two angles are there. The sum of these two is 180 degree. If I say x and y means we can say angle x plus angle y is equal to 180 degree. Okay. So the sum of two adjacent angles are 180 degree, means we can say they are supplementary angles as well as linear pair, like this on a straight line. Okay. And that is it. And there are several examples. In that we have to figure it out what type of angles it is. Do you have a book with you? Okay. Take page number 73. In 73 at the top, do you have axiom 6.1? Okay, then see these examples. What type of angles they are, you should say. Okay. This is like one angle. One is 30 degree, another one is 60 degree. What type of angles this one? Complementary angles. Okay. One is the complement of another one. Okay. Then here, yeah, okay, not a problem. Then what you can say about these two angles? Here 60 degree, here 80 degree. Adjacent angles. Simply, they are adjacent angles because sum is not 90, not 180, nothing is 90. Okay. And then this comes. One side 125 degree, one side 55 degree. Adjacent angles and linear pair, you can say. Okay, because on a straight. Next, here 150 degree, here 70 degree. What you can say about this? Adjacent angles because they share a common arm. Okay. So that gives us the axiom 6.2. What is there in the axiom 6.2? Means if the sum of two adjacent angles is 180 degree. The sum of two adjacent angles is 180 degree. Then the non-common arms of the angle forms a line. Then the non-common arms of the angle forms a line. Quite confusing, right? Okay. 6.1. What does 6.1 say? The axiom 6.1. If a ray stands on a straight line, the angle so formed is linear pair. The angle so formed is linear pair. The same thing 6.2 also say, but in reverse manner. If sum of two adjacent angles is 180, then the non-common arms of the angle forms a straight line. Okay. Both are converse of each other. Okay, front and back. Okay. Then the theorem 6.1 comes. If two lines intersect each other, then the vertically opposite angles are equal. If two lines intersect each other, then the vertically opposite angles are equal. How we can prove? For this, what are all the things we need first? Let AB and CD be AB and CD be two lines. This is proof what I am writing. Two lines intersect at O. These two lines intersecting at O. So we should draw. We'll draw and verify. So here I am naming A, B, C, D. Intersecting at O. In this, what you can say about this? What we need to prove this? Two lines intersect each other. Yes, two lines intersect each other. Then the vertically opposite angles are equal. Which two angles are vertically opposite? We need to prove angle AOC equals angle BOD. That one we need to prove. How do we prove? Using the result that we know already. Take this line. Take this line and we can use the linear pair concept. What you can say about that? In a straight line AB, as per this axiom 6.1 or 2? 6.1. Adjacent angles and the ray stands on it. Then you can say maybe looks like both are similar, but it is really important what we are applying here. 6.2 we can't apply here because we don't know that these two sums are only. All we know is yes, this is straight line and the ray OC stands on it. Okay, ray OC stands on it. So we have this angle AOC plus the angle COB is 180 degree. Okay, so I related this angle and this angle. The same way, either one will take, but that should include this BOD as well, because that is what we need to prove. Right, just like that we have, this is one linear pair. Another linear pair we can say is these two we can say, or these two we can say. Which one will go with? Shall we go with these two? These two will go. Okay, so then this is straight line what? In the line CD, the ray OB stands on it. The OB ray stands on it. Then as per this axiom 6.1, we can say the angle BOC plus BOC or COB, both are same. I'll write like this: COB and BOD equals 180 degree. This is equation 2. That is equation 1. Then any other way these two can be solved and equated. Both are equal to 180, which means both are equal. From 1 and 2, we can say angle COB plus angle BOD equals angle AOC plus angle COB. In this, any equal quantities are there? COB. Okay. This we are cancelling using an axiom that is in the Euclid's geometry. Things which are equal to one another and equals can be subtracted from the equals and the remaining are equal. So these two are equal. These two can be subtracted from these equals. Then the remaining are, you can say, equal. So angle BOD equals angle AOC. It is not like we are writing this objective examination, like we can write the rough work and we'll mark the answer. This is descriptive manner. We should know what we are writing. We should know what are all the things are required to be written. Okay. So that is how this is, but this is not enough for this. After that, you have to write, therefore, if two lines intersect each other, then the vertically opposite angles are equal. Okay. Also, before that, we need to write one. Similarly, we can prove. This two pair we proved. Then COB equals AOD. COD equals AOD. That is all. Clear? Shall I erase? Are you writing anything? Okay, good. Then, yes, is it possible to write that along with me?